So let me say, JAMB is repeating the question. Hi my students, before I begin to solve, before we start solving this question on the board, I want to ask you this. Do you know that there are some areas, some topics that examiners like to bring questions from? Yes, there are some topics that examiners always like to set their question from. If you don't know, let me tell you. Heat is one of them in physics. Do you know why I say so? I've solved a similar, one or two similar questions like this on heat. And as I was searching the past question again, I found out that this type of question it appears again in the past questions. That is why I bring out one of the questions to solve again, so that my students will understand it very, very well. So I advise you to watch on, so that you will understand this type of question that appears most frequently in exams. Yes, especially JAMB exam. Okay, let's take the question. And the question says, a block of aluminium is heated electrically. This block of aluminium is heated electrically by a 30-watt heater. If the temperature rises by 10 degrees Celsius in 5 minutes, the heat capacity of the aluminium is. The question says that they brought a block of aluminium and they used electricity to heat it. When they heated it, the heater they used to heat it is 30 wattage. That is, the power of the heater is 30 wattage. Now, the question says that as they are heating it, the temperature of the aluminium rises by 10 degrees Celsius. Now, let me say this. Note this. Whenever they give you one temperature in question like this, that means they have done the theta 2 minus theta 1. So what do? You use the temperature like that. There's no need to subtract. It's only one, so you can't subtract. They have done the theta 2 minus theta 1. Okay, so they say the temperature rises by 10 degrees Celsius in 5 minutes. Now the question is, the heat capacity of the aluminium is. What is happening here? What is happening here is simply the practical application of the theory of energy, which we know, which says that energy can never be destroyed nor created, but it can be changed, it can be converted from one form to another. Here, electric energy is being converted to heat energy, and for that we say that electricity is giving heat to aluminium. Let me write it out. We say electric energy is being converted to heat energy. Okay, for the question, you can see that it is electricity. The electric heater is giving heat to aluminium. And to uphold the theory of energy, which tells us that energy can never be lost. So we now say that heat given out by the electric heater is equals to, is given out by this electric heater is equals to heat received by aluminium, because heat can never be destroyed, but it can change from one form to another, or it can be given from one object to another. Okay, so we have known that what is happening here is simply the practical application of the theory of energy. That electric energy is being converted to heat energy, which leads us to say that heat given out by electric heater is equals to heat received by aluminium. Okay, now what do? I want to, this thing that I write in words, I want to write it with formula. I want to write it with formula. I will say electric energy. What is the formula for electric energy? We have many formulas, as I always say whenever I'm solving physics. There are many formulas for one question. The formula you use depends on the question given to you. That is the data That is the information in the question given to you. For example, for electric energy, we have the formula IVT, which is current times voltage times time. We also have V square T over R, and we also have for the electric energy, we also have WT, which is power times time. Okay, this is a formula for electric energy. Now come here, which one do we use according to the data given to us? We now look at it. We see W, which is there here, which is for power. What other thing? We see 5 minutes, which is time, which means we use this formula. The data given to us here suit this formula. So I'll write now. I said I want to write this thing that I've written in word in formula. So I'll write WT, which is formula, one of the formula for electric energy. We are using this the third one because it suits the data given to us. WT, okay, is equals to heat energy is MOC theta, is always MC theta. Okay. Now time to substitute value into this formula. Now our W, which is power, is what? You see the number with W is 30. So W is 30. So I write here. I substitute 30 here. 30. Okay. Put my times there. Send me 7 times here. Okay. Now time. Did they give us time? Yes. As I said, they give us 5 minutes as time. But remember, minutes is not the standard unit of time, so we change this 5 minutes to second before we use it. Let's change it. We change it to be 5 times. How many seconds make 1 minute? 60 seconds. So 5 times 60, which will give us 300 seconds. So our time here is 300. Okay, put our equals to mass. Yes, the side of aluminium. Mass. Did they give us the mass of aluminium? No. So how do we get our mass? I want you to know this. Because they asked us to find the heat capacity of aluminium, and specific capacity of any object is the heat that is required to raise 1 kilogram. That's one mass, 1 kilogram of that object. So because they asked us to find the heat capacity, the mass will be 1 kilogram. Because the specific capacity of an object, as I said now, is the heat that is required to raise 1 kilogram of that object through 1 degree Celsius. So the mass, whenever they ask you such question, to find its heat capacity, and they did not give you mass, know that the mass should be 1. So I put mass here, 1. C, we don't know our C. That's what the question asks us to get. The heat capacity of the aluminium. So C, which represents the heat capacity of aluminium, will still be C because we don't know it. That is multiplication sign here. Okay, we come to theta. What is the theta? That is the temperature. You want to say that the temperature rises by 10 degrees Celsius. So our temperature now is times 10. This theta is 10. If we evaluate, we have 30 times 300. I want to take it 1. 3 times 3, 9. Put this 0, put this 0, put this 0. Is equals to what times C? Still 1C. Times 10 give us 10C. So write 10C. Because we are solving to get the value of C, which is the heat capacity of this aluminium, we make it the subject formula. So I write C, this C. C, put this equals to, is equals to, I write this 9,000. 9,000 divided by the number with C, which is 10, divided by 10. And what will it give us? If you cancel this 0, cancel 1 0 here, it remains 900. So our C is equals to 900. 900 what? 900 joule So the heat capacity of this aluminium in this question is 900. 900. And I think in that other question I saw, I still subtain 900 as the answer. So you see that they are just the same question. JAMB is just repeating this particular question year in, year out. So it's better to learn how to solve it. The right answer, you see it in your own exam. So you'll be able to solve it very easy and very correct. Thank you for watching.